Hello students. Well, we're about to start another series of videos, this time on an algebra topic called solving linear equations. So let's just have a quick look at how they fit into the big picture of algebra. So one of the first things you learned about algebra was to work with expressions. So an expression, for example, is 2h plus 3h. And you learned that you can actually simplify that because they're like terms. You can add the two terms and get 5h. The expression 4x plus 6 could be rewritten as 2 times x plus 3. That's called factorizing when you go that way. Or an expression 2 times x plus all of x plus 3 could be expanded to give you 4x plus 6. The second topic you looked at, the second big topic, is relationships between variables. So for example, you might look at the relationship y equals x plus 2. So in this case, x can be any number. You add 2 to it, and you get the value for y. And it turns out you can draw a picture of that relationship, and for equations like that, the picture will look to be a straight line. And here's our new topic down here, 2 outside of x plus 3 in brackets equals 14. Now the main difference between equations and say relationships and expressions is this only has one answer. With expressions, h and x can be any number. Y and x can be any number. But with an equation, what we're doing is trying to find, we've got an unknown number, x. We're trying to find out what its value is to make this equation true. Okay, let's go ahead and start by just taking some English expressions and show you how to turn them into algebraic expressions. In other words, how to turn them into equations. So I'm thinking of a number. Well, I like to use just capital N for my number. Okay, when I add 7 to the number, the answer is 11. So I've got this unknown number. If I add 7 to it, the answer is just another way of saying equals, and the equation is n plus 7 equals 11. And we're not going to solve that equation yet. We're just going to try to get from the English to the algebra. Okay, why don't you stop the video and see if you can write the equations for the next 3 English sentences. Okay, let's see how you went. These are all pretty straightforward. When I subtract 3 from the number, so I take my number, I'm going to subtract 3 from it, and the answer is 9. So my equation is n take 3 equals 9. When I divide the number by 4, the answer is 6. Well, if you recall, the best way to show division in algebra is using the fraction bar rather than the divide sign. So I would write that as n over 4 equals 6. And when I multiply the number by 5, the answer is 20. And the thing to remember there is we write the number first, then the unknown, and then equals 20. And we don't write the multiply sign because it could look too much like the letter X. So 5n rather than n5, or 5n is better than 5 times n. We're using the multiply sign for times. Okay, stop the video and have a go at these slightly harder ones. Okay, let's see how you went on these. So I'm thinking of a number. So once again, I'm just going to use the letter n for that. When I double it and then add 7, the answer is 11. So if I double n, that's just 2 times n, and then add 7, the answer is 11. Well, this one looks almost the same, but you got to be a little bit careful here. Okay, I start with the number. I add 7, and then I'm going to double that. So a lot of students want to write just times 2 there. But the problem with that is that means you're only multiplying the 7 times 2 and not the whole expression. So in this case, we need to put brackets around the whole expression. And then rather than writing times 2 at the back, I'll write times 2 at the front. And again, I don't show the multiply sign because it looks too much like the letter X. So I take a number, add 7, and then double it, and I write the 2 out front and have the brackets around the n plus 7. Okay, this one's got 3 steps to it. First, I add 3 to n, so that gives me n plus 3. I then double it, so once again I have to put times 2, but I write the 2 out the front. And finally, I divide the whole thing by 5. So big long fraction bar and equals 11. So that's an example of what's called a 3-step equation, because you've done 3 operations. You've added, multiplied, and divided. Okay, just a quick word about variables and unknowns. Again, if you're looking at expressions or relationships, X and Y can be any numbers whatsoever at this stage anyhow. Later on, you'll see there are cases when we have to restrict them, but for now, I can put any number in for X and any number in for Y. Here, I can put any number in for X, such as 3, and once I've chosen that number, then I got to figure out what the Y number is that goes with it. In equations, there's usually only one, sometimes two, but usually only one value of X that makes the equation true. So rather than calling them variables, which implies the value of X can vary, we call them unknowns. So X is a number, but we don't know what it is yet. And we solve equations to figure out what the value of the unknown is. Okay, just to finish off, here we have an equation, 6p minus 7 equals 18. And I'm asking you, is p equal to 4 the solution to that equation? So let's go ahead and check it and see. So we just go 6 multiplied by 4, using the dot for multiply. So I just substitute 4 in place of p. That gives me 24. Subtract 7 equals 18. In fact, I always like to write a question mark here because I don't know if it's true or not. And 24 takes 7 is actually 17, so the answer is no. So p equals 4 is not the solution to that equation. Okay, why don't you try the next two on your own and check your answers once you're finished. Okay, students, let's see how you went. So I've got to replace w with 29. So 29 plus 3 all over 4 equals 8. I better make a bit of space for myself here. So I'll just scroll down and I'll drag this. Oops, I'll allow myself to drag that. Yep, get that out of the way and that out of the way. Okay, now let's go ahead and check this. So first we do the 29 plus 3, which is 32 over 4 equals 8. Well, 32 divided 4 equals 8. So that, in fact, 29, in fact, is the solution to that equation. Okay, the last one. 4 outside of 5, take 8. Equals negative 12. Oops, I should have put a question mark there because I don't know if it's true yet. Okay, 5 take negative 8 is negative 3. And 4 times, I might write that a bit more like a negative, 4 times negative 3 does equal negative 12. So V equals 8 is the solution to that equation. Okay, so we'll stop there and continue with our study of solving linear equations in the next video.